Digital Learning Days, week 3, day 3. Number 1 says, what is 2.8 times 10 to the 4th power times 5.25 times 10 to the 1st power? Write your answer in scientific notation. So, y'all know I've got a little bit different calculator here at home, and I'm sure you do too. So I had to kind of play around with it in order to get scientific notation typed in there. And I came up with 1,470,000 as my answer in standard form, but my question asked me to write my answer in scientific notation. So now I have to take this, my decimals here, and I have to make this a number in between. I have to move my decimal until I have a number in between 1 and 10, greater than 1 and less than 10. So I'm going to move it 1, 2, 3, 4, 5, 6 times. So that's going to give me 1.47. I can write those zeros, but I don't have to. Times 10 to the 6th power, because I moved my decimal 6 times. And that is my final answer. Number 2 says, what is 5 to the negative 3 power in standard form? Standard form means we're just writing it as a regular number, no exponents. And so when I have a power that is negative, I'm going to keep my base, change my exponent to positive, and put all that under 1. So I have 1 over 5 to the 3rd power. Then that's exponential form. So that means I have 1 to the 5 times 5 times 5 power. That is expanded form. It asked me for the answer in standard form. So then I'm going to do 5 times 5 times 5 equals 125. So 1 over 125 is my final answer in standard form. Number 3 says, find the missing side length of this right triangle. And it gives us, it looks like that's an 11 and a 61. It gives us the right triangle. We need to know that this is our right angle here, and the leg that the right angle is pointing towards is our hypotenuse. So that is our C, and then these other 2 sides are our A and our B. So I've written my formula, a squared plus b squared equals c squared. That's the formula for Pythagorean theorem. Whenever we have a right triangle, we can use the Pythagorean theorem to figure out leg lengths. And I plugged in my given information. So A is 11 squared, B is what I'm solving for, and C is 61. So I have 61 squared. And I'm going to put that in my calculator. That's going to be 121 plus b squared equals 61 times 61, or 61 squared, which is 3,721. Now I want to subtract 121 because my goal is to get b on a side by itself. And this is going to create a 0 pair. So I'm left with b squared equals 3,721 minus 121 is 3,600. And I don't want to know what b squared is. I want to know what b is. So in order to get rid of this squared, I have to do the inverse, which is taking the square root of. But whatever I do to one side, I have to do to the other side. And that's going to give me the square root of 3,600, or 3,600 is 60. So B equals 60. And that makes sense because my legs have to be shorter than my hypotenuse, and it is. Even though it's just 1 unit shorter, it's still shorter. And let's see, on our original picture, it says centimeters. So we need to make sure we include our unit of measurement in our answer. Number 4 says, give the domain and the range for the data set. So yesterday, we highlighted our input in blue and our output in red. And domain is another word for input, and range is another word for output. So I would just list our blue numbers, all of our inputs under domain, and all of our outputs under range. And I'm going to actually do this in order from least to greatest. And it appears that our domains are already in order. So I have -1, 0, 2, and 3. And our ranges are not in order. So I'm going to list those from least to greatest. I have -1, which is this -1 here. 3. We have another 3. Remember, when we're listing domain and range, we don't have to list that twice. And 5. So those are our domain and ranges. And then number 5 says what type of transformation is pictured here. And I can tell that, let's see if I can point to it here. Because all of these are, we have C is 2 points away here, C's 2 points away here, A, and B. This looks like a reflection over the y-axis. So that would be my answer for number 5, is a reflection over the y-axis. You guys have a great day.